Easy case. Let's look at a special case. And we've kind of looked at this before when we did completing the square. So you might recognize this expression already. Notice here, this happens to be a perfect square trinomial. Half of negative 12 is negative 6. You square that, we get 36. So right away, we should recognize that this is actually going to be x minus 6 quantity squared. Or it really is just the exact same situation that we had before. If we needed two numbers that multiply together to give us 36, but add together to give us the negative 12, because subtraction is actually adding the negative, well, that's great. Negative 6 times negative 6 is equal to positive 36, and negative 6 plus negative 6 is equal to negative 12. Those are the numbers that we want, negative 6 and negative 6. So this is x plus negative 6 times x plus negative 6, or like we saw when we were completing the square, we could just write this as x minus 6 quantity squared. Now, notice here again, we were in an easy case where the coefficient of x squared is 1. Let's try something a little bit more difficult. Example 2. Let's suppose we have something that looks like this. 4x squared minus 12x plus 9. And we want to factor that. Now notice here in the example 1, the x squared is going to come from this x times this x. This 4x squared, well, we need two things that are going to multiply together to give us 4 times x squared. Notice that 4x squared, that is actually 2x squared. And this 9, well, just like over here, this 36 came out of negative 6 times negative 6. So this 9 is actually the square of negative 3. Now, here's the nifty thing. This value in here, 2x, and this negative 3, well, that gives us negative 6x. And that is actually exactly half of our linear term, which is actually negative 12x. That's what we need. So since this is the situation that we have, 2x plus negative 3 squared is exactly what we want. And let's see how this comes about just by checking it. 2x plus negative 3 squared, well, that is, of course, 2x plus negative 3 times 2x plus negative 3. Now we just distribute this out and multiply it. So this whole factor times 2x plus this factor times the negative 3. Distribute this back in. 2x times 2x is our 4x squared. 2x times negative 3 would be a negative 6x. Negative 3 times 2x is a negative 6x. And then finally, negative 3 times negative 3 is a positive 9. Notice how we combine the like terms here. 4x squared plus negative 12x plus 9, which is exactly what we started with. That's what we wanted. The whole big idea here, and we've seen this before, is that a plus b quantity squared is a squared plus 2ab plus b squared, or a minus b quantity squared is a squared minus 2ab plus b squared. So basically, if the linear term here is the square root of the quadratic term times the square root of the linear term, or excuse me, the constant term times 2, then we've got a perfect square trinomial. Right? Square root of 4x squared is 2x, Square root of 9 is negative 3. Multiply them together, we get negative 6x. That's half of the linear term. What we're seeing right here. These are things that you should have down pretty well. Let's try one more here. 25x squared plus 20x plus 4. Notice here, first thing you should be looking for, is this quadratic term a perfect square? Sure. 25x squared is actually 5x squared. 4, that's a perfect square. This 20x, well, let's see here, 5x times 2. But then 2 times all that, yeah, that becomes 20x, that linear term. So now we know that 5x plus 2 squared is the factored form. And of course we should check that. 5x plus 2 squared is equal to 5x plus 2 times 5x plus 2. 5x plus 2 times 5x plus 5x plus 2 times 2. Distribute the 5x back in. 5x times 5x is, of course, 25x squared. 2 times 5x is 10x. 5x times 2 is another 10x. 2 times 2 is 4. So notice this is where that whole doubling the product of the quadratic term and the linear term, or the square roots of those two terms, comes into play. So this is, of course, 25x squared plus 20x plus 4. Exactly what we wanted. So, again, take the square root of the quadratic term, in this case it would be 5x. Take the square root of the constant term, which in this case would be 2. Multiply those two things together. Oops, this should be 20x. And that should be half of the linear term. So 2 times the product of those two square roots. If that is equal to the linear term, then we've got ourselves a perfect square trinomial, and it factors quite simply like that. Next special case, the difference of squares. So here we have a really easy one, x squared minus 4. Well, again, here our coefficient of x squared is just 1, so really we're back to a really easy example. And so we need two numbers that will multiply together to give us really the negative 4 here, because x squared minus 4 is really x squared plus negative 4. But then those same two numbers need to add together to give us the coefficient of x. Wait, there isn't one. Oh yeah, that means it's 0. So we need two numbers that when we multiply them together we get negative 4, but when we add them together we get 0, because this is really x squared plus 0x plus negative 4. And the two numbers that work for that are, of course, 2 and negative 2. The product of those two things is negative 4, and the sum of those two things is 0. So we know that this whole thing factors as x plus 2 times x minus 2. Okay. The big idea here is that a plus b times a minus b is equal to a squared minus b squared. And you can multiply this out to verify that for yourself. Let's do one more example here. Something a little bit more difficult. 16x squared minus 81. Well, 16x squared, that happens to be 4x squared. So 4x is really kind of like a down here. 81, that's 9 squared. So the 9 is like this b here. So this whole thing has to be equal to 4x plus 9 times 4x minus 9. And of course we can always check our answer just to see if it actually works. We've just multiplied this out again. 4x plus 9 times 4x minus 9, or really 4x plus negative 9. I just like that because it means I don't have to deal with any subtractions. So this is 4x plus 9 times 4x plus 4x plus 9 times negative 9, which is equal to 4x times 4x is our 16x squared. 9 times 4x is 36x. 4x times negative 9 is negative 36x. And of course, 9 times negative 9 would be negative 81. And the great thing here, notice that the two linear terms here, 36x and negative 36x, those are going to cancel each other out, leaving us with 16x squared plus negative 81, which is what we wanted, which that's exactly what we started with. Easy. And it really all just comes out of this right here. Let's do one more example here. Oh, wait, not even another example. I'm just going to leave you guys with some practice problems. So factor each of these three expressions as the product of two linear binomials. Have fun with it.